So let's find the curl of this vector. So solution, curl of the vector V is given by grad operator cross the vector V. So this can be written as a determinant. So curl of V is I partial X plus J partial Y plus K partial Z. And then you cross this one with X squared minus Y squared plus 2XZ plus XZ minus XY plus YZ Z squared plus X squared. So which can be written as a determinant. So that's how we write the curl of V. Now, which should be given by. So expanding along the first row, we know that this has plus sign, minus sign, plus sign. Partial Y of this vector will be 0. Minus partial Z of this one will have minus X and then minus Y. Minus J, close this column, close this row. Partial X of this one will have 2X. Partial Z of X squared minus Y squared plus 2XZ is plus K. So partial X of this will have Z minus Y, and then partial Y of this vector will be minus 2. So minus is plus 2Y, which will give us, we can write this one as negative X plus Y I. This will be 0. So I can write plus 0J, and then this will give us plus Y plus Z, cos minus Y plus 2Y is Y, then K. So this will define the curl of the vector V. Now let's calculate the curl of the vector at the specified points A and B. So i.e., this is just the same as saying curl of V is negative X plus Y I plus Y plus Z K. Now, the curl at the first point A, given by 1, 2, minus 3, is, so where there's X replaced by 1, Y by 2, Z by minus 3, I'll have minus into 1 plus 2, I plus 2 plus minus 3k, which will be minus 3i, and then minus k. And then the curl v at the point B, whose coordinates are 2, 3, 12, is, so we'll have negative 2 plus 3i plus 3 plus 12k, which will give us minus 5i plus 15k. Then to show that two vectors are, so we can actually call this one, let's call this one V1, let's call this one V2. So V1 and V2 are perpendicular if and only if their dot product is 0. So V1 dot V2 is 0. So let's see that V1 dot V2 will give us, so negative 3 multiplied by negative 5 plus negative 1 multiplied by 15. This will give us 15 plus minus 15, and the answer is 0. So indeed, the dot product of the two vectors is 0. Hence, V1 and V2 are perpendicular vectors. When another name for perpendicular is orthogonal. So that's how we're supposed to work out the solution for that particular problem. Thank you.